In this video, we will work on chapter 12 in class exercise 6, problem number 12-204, absolute dependent motion analysis. The cable at A is being drawn towards the motor at velocity 8 meters per second. Determine the velocity of the block. So this cable is being pulled by this motor at this speed, 8 meters per second. We need to know at what speed the block B moves up. So first step is we need to identify how many different physical cords are there in the system. So there are two physical cords, one going all the way from the ceiling onto pulley B to pulley C and back to the center of pulley B. This is one single cord. And then there is another cord which is going from center of pulley B to the motor. Okay. So this is first step. We have identified that there are two cords. Let's call this cord number 1 L1 and let's call this cord number 2 L2. Now define the datum. The datum should be a fixed reference point, and this is a good reference point because it does not change with time. So center of pulley at A is the datum point, and relative to that datum we define the position vector for the center of block, which is SB, pulley B. Now see, pulley B and block are attached with a fixed cord, and this cord does not change the length. So whatever is the position of pulley B or the velocity of pulley B, that will be the same as the velocity of the block. Okay. Then pulley C moves up and down, so its position changes. So we define another position vector for pulley C. Let's call this SC, and they both are used for like cable 1 and 2 respectively. And the last step is we need to define the position vector for A, which is given by SA. So as motor runs, A moves and the position of A changes. So we have three position vectors: SA positive going towards the motor, SC and SB positive going down. Okay. So now it's time to write down the equation for length of the cable L1. So L1, length of the cable, is SB plus twice of this, so 1 and 2, and that is SB minus SC. So this gap here is SB minus SC, and we have two segments of the cord, so it's SB plus 2 times SB minus SC, and that is nothing but 3SB minus 2SC, and this is equation number 1, length of cord 1. Now length of cord 2, L2, is this segment here, which is SC, plus this, which is SA. So SC plus SA. So this can be written as SC plus SA. That's equation number 2. Now remember, we haven't included any length of the cable that does not change with time. For example, this small section here, we haven't included because it does not change with time. Even if we include it here, when we take the derivative, that portion will be 0. So include only those segments of the cord which change with respect to time. So now let's take the time derivative of 1 and 2, these two equations. So it's dL1 by dt is equal to 3 dsB by dt minus 2 dsC by dt. Now total length of the cord does not change, so it is 0. However, SB and SC change, so this is 3, and this can be written as velocity because it's change in position relative to time, and this is velocity of C. So this is equation number 3, and taking the derivative of second equation, dL2 by dt equal to dsC by dt plus dSA by dt, and this is also 0. Total length does not change, so this is VC plus VA, and that's equation number 4. Now we can eliminate the VC from both these equations by substituting VC is equal to minus VA into equation 3. So from equation 3, It's 0 is equal to 3VB minus 2 minus VA. And that's equal to 0. Therefore, 3VB plus 2VA is equal to 0. So this is very important for us to know because this equation relates velocity of B with velocity of A. So this is minus 2 times VA divided by 3. And that's what we were looking for. So we have been given velocity of A and we need to determine the velocity of the block, which is this attached to pulley B. And since they are attached with the fixed cord, velocity of pulley B and block are the same. So now we can substitute the given value of VA here, which is 8. So the answer is minus 5.33 meters per second. Now, why do we get the negative value for velocity of the block? Is because the positive direction is defined going down, but when the cord goes towards right, when the motor pulls the cord, the block actually moves up. It moves up means it moves in the opposite direction of its positive direction. That's why we get the negative sign. If this number was positive, that means block goes down, and the number is negative, that means block goes up. Okay, thank you.